All right, guys and gals, we're going to keep going in our 7th and 8th grade geometry unit. Today, we're going to talk about a topic known as surface area. So before we get into all the ins and outs, let's talk real quick what we mean. So for example, this is a printer cartridge out of my printer here at home. And if you notice, it is a rectangular prism. Notice the bases, maybe we call this side a base and this side a base. They're rectangular. They look square, but they're rectangles. And then all of the faces, so all of the rest of the sides here are also rectangles. Now, obviously, it's not a perfect rectangular prism. Obviously, we've got a little bit of extra here with this clip that helps hold it in place. And this little nozzle at the end, that's where the ink comes out. But this is a rectangular prism. And what we're going to do today in our work is we're not so concerned about this being a three-dimensional object. Instead, what we're concerned about is this two-dimensional space on the surface. So if I were to ask you, well, what's the surface area of this particular object, what I want to know is how much two-dimensional space is occupied on each of these surfaces. So what I would do is I would find the area of this face and add it up to the area of this face, add it up to the area, you get the idea. Since there are 6 faces, I would have to do this 6 times. So if you think about that, that's really inefficient. What we're going to do today is I'm going to show you different formulas that will allow us to find all of these surfaces all in one go. That should save us a little bit of time and energy. All right. And we're not just going to talk about, say, rectangular prisms. We're also going to talk about, say, triangular prisms. We'll also talk about cylinders, pyramids, as well as cones. So we're going to look at surface areas. So again, we're measuring in a two-dimensional sense on a three-dimensional object. All right? So let's get into it. The first object that we're going to look at are prisms. All right. And the formula for their surface area is as follows. Now I'm going to write it out and explain each part. It's not near as complicated as it looks. So we're going to abbreviate surface area as SA, all right, surface area. And the surface area of a prism is equal to the following. It's equal to 2b added to ph. And let's talk about each of those ideas, all right? So 2 is pretty obvious. It's just the number 2. The b, let's write it over here. The b is equal to the area of the base. So for example, if I'm looking at my rectangular prism here, this is a base. So what I'm going to do is I'm going to calculate its area and then multiply it by 2. And again, we'll do an example here in just a few moments. But again, this is the base, this is the base. And since there's 2 of them, that's why we're multiplying by 2. So I'll find this area and this area. Notice there's 2 of them. So we could find just one and multiply by 2. And now we've got the top and the bottom covered, right? We've got those areas figured out. But then we need to talk about the rest of it, all right? So let's talk about the next part of the formula. P, let's change colors. P is equal to the perimeter of the base. In other words, again, here's our rectangular prism. The perimeter in this case is the distance around here, right? The linear distance. So maybe it's 1.5 inches this way and 1.5 inches this way and 1.5 inches, whatever the dimensions are. I'm not exactly sure. It's not a perfect square. So again, that's all it is just the perimeter around. And then the H, let's see if we can get one more color in here. The H represents the height of the prism. So our height in this case is measured from base to base, so it would be this dimension here, right along this long edge. All right. So what we're going to do is find the base area, multiply by 2, because remember there's 2 bases on a prism, and add to that the perimeter, so the distance around, multiplied by the height, and that'll get us the rest of these surfaces all in one go. So let's do an example. All right. So as you draw these out, take your time, don't rush. Let's do a rectangular prism first, and then we'll do a triangular prism second, just so that you can see this formula will work for any prism you come across. So let's do a rectangular prism first. So I'm going to draw my rectangle here. All right. And the base is also a rectangle. So we'll draw a dotted line there. There we go. That's looking okay. And then over. All right. So let's talk about the dimensions here real quick. So my base in this case is the top here and the bottom here. All right. So I'm going to write out our dimensions. Let's see. In this case, our dimensions are 4 centimeters across here, 3 centimeters front to back. All right. And then from top to bottom, so our height is 10 in this case, 10 centimeters. All right. So let's use this information to see if we can calculate the prism's surface area. All right. So the first thing I'm going to do is figure out my B. All right, so I'm going to rewrite all of this actually. Let's do it over here. Surface area is equal to 2B added to PH. All right, so let's start with B. Remember, B is the area of the base. So let's look at our base here. Here it is at the bottom. My area is a rectangle here, so it's going to be 3 times 4, and that's 12. So let's rewrite this. Our surface area is equal to 2 times the area of our base is 12, because notice both bases would be the same size. So 3 times 4, that is 12. And I'm not so worried about working this out just yet. Let's get everything plugged in first. All right, add it on. Now, we've also talked about perimeter, and remember, the P represents the perimeter of the base. So if I've got 4 centimeters here, that means on this back edge, it's also 4 centimeters. And if it's 3 centimeters across this edge, then it's also 3 centimeters across that edge. So if we add all of this up, I've got 3 and 4 make 7, another 3 and 4 make 7. So that perimeter then would be 14. So let's write that down, 14 for the perimeter. Last but not least, we're going to multiply by the height. So in this case, the height, remember, is from base to base. So in this case, 10 centimeters. So let's write that 10 in there. All right. Now, if at any point the math gets to you, by all means, feel free to use a, I don't know if mine will work, feel free to use a calculator. All right. Well, if it'll let us. There we go. So all we got to do is type in what we see, and that'll give us our surface area. So we know 2 times 12, that's 24. And we know 14 times 10, that's 140. And again, if you need a calculator, feel free. In this case, we've got, what is that, 164 would be our surface area. Now let's talk about units. Since we're measuring in centimeters here, we would write our final answer as 164 centimeters squared, right? This is an area measurement. So all area measurements are saying how many of these little squares could I put all over the surface of this figure? Or if we were looking at this three-dimensional object, and I'm going to draw a square on here, maybe we've got these little bitty squares, all right, that we're going to cover it in. How many of those teeny tiny little squares would it take for me to cover this surface and this, all 6 surfaces? So in this case, it would take 164 of those little bitty squares to cover the entire surface. All right. Let's try a triangular prism just so that you can get the idea there, and then we'll move on to another figure. Triangular, let's see if we can get a triangle drawn here. Well, let's draw that, just kind of separate it. I don't know. I'm not very good at drawing triangles that meet up nice and neat. That'll work. We'll come down. We'll make it kind of look like a wedge of cheese or something here. There we go. Dot, 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 dot. And then we'll draw across here. It helps if you make the noises. Dot, 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 dot. And dot, 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 dot. Okay. Let's start putting in all of our measurements. So in this case, pick up my pen. This edge over here is 7. We'll go with inches this time. So 7 inches. This edge across here on our base is 3 centimeters. Oh, let's see here. This, and we'll talk about this in a minute. This is the height of this bottom base, or the top base, however you'd like to call it, and it is 2.6 centimeters. Our height from base to base here, notice that's the height of just this triangle. This is the height of the actual prism, is 5 centimeters. And then this other edge that we've got here is 8 centimeters. Excellent. So the nice thing about the prism formula is that it doesn't matter what kind of prism you've got, this formula will always work. So let's get started. Actually, I'm going to do it over here where I have space. So we're going to use our talking point section to do this work. I just sort of ran out of space there. So our surface area this time, again, still equal to 2 multiplied by the base area, added on to the perimeter multiplied by the height. So let's start getting everything together. Now notice the base here is the same as the base on the bottom. So notice that's 8 centimeters. That means this edge here is also 8 centimeters. So I'm going to write that in. Because notice the first thing I need is the area of the base. So take a look. If you don't remember the formula for a triangle, let's deal with it. So what you do is you take the base of the triangle, so in this case 8, there we are. We'll multiply it by the height, so in this case 2.6. I switched from centimeters and inches. Daggone it, I just realized that. I was looking at the problem up there. This is all in inches. Inches, 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 and inches. Good Lord, it helps if your math teacher can read. Here we go. So we're going to take that 8, multiply it by our height. So notice the height of the base here is 2.6. And remember, when we find the area of a triangle, we divide by 2. Cool. So that's one base. All right. But notice our formula here is to multiply it by 2. So let's do that. So 2 times 10.4 added on. And again, we'll deal with that in a minute. Perimeter. So the perimeter is all the way around. So notice I've got 3 and 7. That makes 10. Added 8 is 18. So my perimeter of the base is 18. And then I'm simply going to multiply by the height of my prism, in this case, 5. So let's get to it. I'm going to take my answer here, this 10.4, multiply it by 2, and then we'll simply add on our 18 multiplied by 5. Uh-oh. There it is. Multiplied by 5. It did take, I thought it did. So in this case, our surface area is 110.8. And in this case, inches, if I can get our units right, squared. So again, if I had 110 1-inch by 1-inch squares, they would completely cover this figure, almost 111 of them. All right. So there are prisms. They're pretty straightforward. And again, you will have access to the formulas. We'll be working with those and showing them to you. I might even make you guys a little cheat sheet for class purposes. That way you're not having to look up at the board or always flip back and forth to your notes. Okay. So let's try something else. And this time, let's try cylinders. Now, cylinders' surface area formula is fairly straightforward. I'm going to show you 2 different versions of it. One that you might see, say, on a quiz or a test, maybe in high school, and then one that I'm going to show you that's going to make your life easier. Their version of it is 2 times the area of the base. So notice that's very familiar, right? Those look the same. Added on to the circumference by the height. So notice these 2 formulas are exactly the same, whereas perimeter is the distance around, say, a polygon like a rectangle. C is the distance around a circle, all right, the circumference. So that's one version, and I like it okay. Here's the version that I'm going to use, all right? And again, this one's perfectly valid. It works great. But here's the version that I'm going to use with you guys because I think it's a little bit clearer because it shows you exactly what you need. This version of the formula is as follows. You're going to take, let's see here, 2 pi times the radius squared. Notice pi r squared is an area of a circle. Okay, again, the area of the base. And you need 2 of them. So I've just simply taken this and wrote it out for a specific case, in this case, our circle. Let's see here. The other part of it is 2 pi r h. So let's talk about each part. And again, this first version, it works, but I'm going to be more focused on this version. So let's talk about each part. First is pi. And I think we all know pi's approximation is about 3.14. Do be careful. See what your work wants you to do or the test that you're working on. If they want to use 3.14, cool. Otherwise, if they want you to use a pi button like we have there, go ahead and use it. R is equal to the radius of the base. Okay. And then notice we got pi and radius again, so we'll use those twice, as well as a 2 twice. The last thing we need is h, and it is simply the height of the cylinder. So let's draw one out. Do an example. All cylinders work the same. And again, if you're like, what is he talking about cylinders? So for example, I've got an old case of CDs here. Take a look. We've got a circular top. Okay. It's smooth all the way around the edge, so it's not blocky like what we had here with our prism. A cylinder, again, got a circle on top, circle on bottom, and then that smooth surface all the way around the edge. All right, so like a pop can, old CD case, that kind of thing. So let's draw one, and we'll do an example. Let's see if I can draw a decent base for this. Hey, that's not too bad. And we'll draw it down here just a little bit. And then we'll kind of dot that other side there, the rest of that edge, because we can't see it. Oh, let's get some measurements on here. Let's go crazy. How about 6 kilometers for the height? We're talking about a really, really big cylinder here. And then let's give it a radius of, I don't know, how about 5 kilometers? That sounds good. All right, so let's use our formula. And again, I'm going to use this one just because I think it's easier. So let's write it out again, get practice writing it out. So surface area in this case is equal to 2 pi r squared added on to 2 pi r h. And we're going to fill out each part together, no worries. We're going to use 3.14 for this, just so that way we get the habit of using that approximation. Again, we'll maybe practice in class using just the pi button so you can see both. So let's get started. First thing we're going to have is the 2, all right, that doesn't change, multiplied by pi, so 3.14, multiplied by, let's find our radius. R stands for radius, so in this case 5, so we'll write it as 5 squared, add on, 2 stays, 2 is part of the formula, pi we already know, 3.14, multiplied by our radius again, so in this case 5, multiplied by our height, and remember height is measured from base to base, so in this case 6. Now, I strongly recommend in this case using a calculator simply because the numbers that we're going to get are going to get really big really fast. Plus, dealing with pi is not a lot of fun. So here we go. Let's type it in. So 2 multiplied by 3.14 multiplied by our radius, so in this case 5 squared, added on. And again, your calculator should follow the order of operations, so it should multiply both sides first before it adds together. 2 times pi, so 3.14, multiplied by our radius, so in this case 5, multiplied by our height, in this case 6, and there is our answer. So in this case, surface area is 345.4, in this case kilometers squared. Remember, we're talking about how many of these squares, so in this case they'd be really big squares, 1 kilometer by 1 kilometer would fit roughly 345, almost 346 of them all over this particular figure. And again, since all cylinders are similar in this nature, having circular bases only, we only need the one formula and we can get very specific. We'll notice here it's a little bit more general and it depends on the area of our base. All right. Well, let's move on. We've got, what do we got next? Pyramids. Pyramids. Oh, gotta love pyramids. Let's see here. Pyramids. Pyramids. Now, pyramids are a little different. Okay, their surface area formula is as follows. Okay, pyramids have a surface area, and I'm going to show you. The calculator-friendly version. All right, it's P multiplied. This is an L. All right, this is a cursive or a scripted lowercase l. So PL divided by 2. And I know we said that we don't want to write division this way, but for our purposes we will, and we'll talk about that in a second. Added on to B. All right, so let's talk about each part. Hopefully by now you're comfortable with what P represents in this case. P is the perimeter of the base. Okay. The scripted L is what we call the slant height. All right, we'll talk about what we mean by slant height here in just a second. We should all be familiar with the number 2, so that's not too difficult. And then last but not least, B, we should be familiar with that as well. That is simply the area of the base. So let's draw a pyramid and see what we can do. How about, I don't know, let's do a square pyramid. Since our formula works best for that, let's try our square pyramid here. So let's see if I can draw a decent square, something like that. And we'll draw up, like that, and then dot, 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 and then dot, 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 and then dot, 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 dot. That's pretty good. Again, it helps if he makes the sounds. So let's get our measurements in here. In this case, our base measures 5, meters by 5 meters. It's a square at the bottom, kind of like the pyramids at Giza. And then let's talk about slant height. Slant height is measured from the top. By the way, we call this the apex. From the apex along the side to the center of the base. All right. So I don't have a pyramid. But for example, if we were looking at, say, the corner of a pyramid, maybe this is our pyramid side, it would go from the apex all the way down to the center of the side. So in this case, our slant height for this particular problem, and I had an example drawn just a second ago, there it is, 6.5 meters. All right. So let's find our surface area. Surface area is equal to the perimeter of the base. So in this case, I've got 5, 10, 15, 20, remember 5 all the way around. So 20 multiplied by our slant height. So in this case, our slant height is 6.5. 6.5. And then divided by 2. And notice the only reason I'm showing you this way as opposed to a fraction is it'll just be easier to type into our calculator. Last thing we need is the area of our base. And notice we only have one base because in pyramids, we just have the base that it sits on. There is no base at the other end. There's just that point, the apex. So in this case, the area of our base would be 5 times 5. So that is 25. All right. So let's see what we get. And again, sometimes these numbers will be easy to crunch, sometimes not so much. In this case, we'll just grab a calculator. So 20 multiplied by 6.5, 6.5, divided by 2. It's the arrow over there, added on to 25. So in this case, we get 90 as our surface area, so 90 meters squared. Right. Pretty easy, pretty straightforward. So pyramids aren't too bad. We'll take that perimeter, multiply it by the slant height, divide by 2, and then we'll add on the area of the base, whatever it happens to be. All right. Let's move on to another similar figure, not exactly the same, but similar. And that is the cone. All right, the cone. Now, its formula is going to look kind of like the prism, not exactly, but close, and kind of like the pyramid. Again, not exactly, but close. All these figures are somewhat related. In this case, our surface area is pi times the radius times the slant height, and we'll add on pi times the radius squared. Because notice, pi r squared is the area of a circle, so notice that's our base. Pi multiplied by the radius is somewhat of a circumference measure, so again, similar to that perimeter. And then, of course, we got slant height in there, similar as we did to our pyramid. So and I'm not going to write all those out. Well, I guess we might as well. We're here. So in this case, pi, we know is approximately 3.14. We know that L is equal to slant height. And then let's see, what else do we need? Oh, radius, forgot radius. Radius of the base. Cool. So let's get one drawn. I'm not very good at drawing cones. Always end up making the circular bottoms look weird. Here, let's try it this way for a change. Always draw them like up and down like party hats. Let's draw like an ice cream cone this time. So let's see, we'll draw our base here. That's not so bad. Bring it down. Yeah, that's not too bad at all. All right, well, let's get our radius drawn. In this case, we'll say 8 centimeters. And our slant height, so it's measured along this edge here, I'm going to kind of bold it in a little bit, is 17.9 centimeters. All right, and we need to find its surface area. So here we go. Surface area for a cone is pi times the radius times our slant height added on to pi times our radius squared. So all we got to do is plug in the numbers just like we've been doing, and we'll be good. So let's start off pi, and I'm still going to use 3.14. So let's see, 3.14 multiplied by my radius. So in this case, 8. Again, from center of the circle to the edge, so 8. Multiplied by our slant height. So in this case, 17 and 9/10 centimeters. Added on to pi, so 3.14. I'm almost out of space. Multiplied by our radius, in this case, 8 squared. Whew, just about didn't make it. Here we go. And again, when dealing with pi and all of these things, it's going to be a lot easier if we just grab a calculator. So here we go. 3.14 multiplied by 8 multiplied by 17.9 added to, let's see, pi, 3.14 multiplied by 8 to the second power, because again, that is our radius measure. And in this case, we end up with a rather large surface area. In this case, though, it's a pretty good size cone of 650. Now I'm going to round to the 10th position. So that's a 6. We go over, it's a 0, so we'll round down. So 50.6 centimeters squared. So again, if we had 650, almost 651, 1 centimeter by 1 centimeter squares, we could cover that entire cone, again, with 650 of them. So again, that's what we're doing today, surface areas. That gets you a good start. You've got all of your formulas. Okay, you've got examples, okay, of each one, and we'll do these in class. And again, sometimes we'll have to make exceptions, like whether we're dealing with, say, a square base, or excuse me, rectangular base versus a triangle base with our prisms. But for the most part, if you know these formulas and can work them, you'll be fine. All right. If you have any questions or concerns, let me know. Otherwise, have a good day, guys and gals.